Good morning, Year 5, and welcome to your maths lesson. I got very excited because since I last filmed for you, I've had some new glasses arrive, which are meant to block out blue light, but the problem is that when I put them on, you can just see the reflection of everything on the screen, which you can't see with my other glasses. So I'm going to have to keep persevering with not using them. Anyway, for maths today, let's have a look and see what we've got. Here is your starter question. Ava says, I know that 3/4 is equivalent to 3/8 because the numerators are the same. Is Ava correct? And can you explain why? I will put this in the as a resource in Teams for you to type underneath to have a go at answering. Is Ava correct? And how do you know? Okay, so hopefully you were able to tell me that Ava is incorrect. Now, we know that fractions can be equivalent if they are the same size, but if we have a look here, I have stolen my 4/4 and my 8/8 from my fraction wall, and I can highlight where 3/4 comes up to here and 3/8 comes up to here. So I can see that they aren't equivalent. If I come down, then I can see that 3/4 is the equivalent of 1, 2, 3, 4, 5, 6 eighths. So there is a way of making quarters and eighths equivalent, but 3/4 and 3/8 are not equivalent. They are not the same. So let's have a look through. So we're looking at exploring equivalent of fractions again. So I will put in the same resources that I put in yesterday with the fraction walls because they can be really, really beneficial as a way of seeing it quite visually. So a fraction represents a part of a whole, and equivalent is when two things are the same. And let's remind ourselves really quickly of how that can look. So here we have a whole, and I can split it into two halves. And I know that it's been split into two because my denominator shows me how many equal parts the whole has been split into. I can also split it into quarters. I know it's been split into 4 because my denominator is 4, and that shows me that it's been split into 4 equal parts. If I have a look over here and shade with my highlighter, I can see that these two are exactly the same. And I can see up here is 1/2, and it's exactly the same. It's equivalent to 2/4. So if I'm writing that as an equation, 1/2 equals, that's very big, 2/4. Now, if I have a look at that with our shapes here, if I've got my whole here, it's split into two because I've got it split into two parts. I can tell that from my denominator. And I'm shading one of those parts in. I can tell that from the numerator. So I'm going to very quickly and not particularly tidily shade in 1/2. Now, if I have a look next to it with 2/4, I've got it split into 1, 2, 3, 4, as it says from my denominator, and I'm going to shade in two of those. Now, if I do this nice and quickly, I can see that I've got the same amount of the shape shaded in, which tells me that 1/2 is equivalent to 2/4. Now, we can work that out without needing to use shapes to help us. If I have a look at my numbers, I'm going to look at the numerator first. So to get from 1 to 2, there are some things that I can do for that. But when we're finding equivalent fractions, we always multiply or divide. Now, to get from 1 to 2, I have to multiply it by 2. Now, whatever I do to the numerator, I also have to do to the denominator. So I have to do the same thing to the denominator. And 2 times 2 gives us 4. So I can see that those fractions are equivalent. And I can do the same the other way around. So if I had 2/4 and I was trying to find an equivalent fraction, I could divide both the numerator and the denominator by 2 to find out an equivalent fraction. So let's have a look at some examples. So here I've got two equivalent fractions. And the first thing that we need to do is we need to work out what those fractions are. So in this shape, I'm going to first of all work out the denominator. I know that they are equal, so I can put my equals in. The shape, the whole is split into 1, 2, 3, 4, 5, 6, 7, 8, 9 equal parts. So my denominator is 9 1, 2, 3 of them have been shaded in. Now for my second shape, my whole has been split into 1, 2, 3 equal parts, and one of those parts has been shaded in. Now I have a look at my equivalent fractions. To get from 3 to 1, I have to divide by 3. I'm slowly getting better at using the mouse for this. And to get from 9 to 3, I also have to divide by 3. So I can see that that has worked. Now let's try the next one. And let me see if we can get it to work without counting it first of all. So I'm sorry, without counting the second one. So I've got my first shape, my first whole has been split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal parts. And 1, 2, 3 of them are shaded in. Now, if I look at 3 12s, 3 and 12 can both be divided by 3. So if I divide 3 by 3 and 12 by 3, because I have to do the same to the numerator and the denominator, then in theory, I should end up with 3 divided by 3, which is 1, and 12 divided by 3, which is 4. Now, if I have a look at my second whole, it's been split into 1, 2, 3, 4 equal parts, which is correct, and one of them is shaded in, which is also correct. So I can see that I can use my division and multiplication facts to help me to find out the equivalent fractions. Let's look at one last one. So our top whole has been split into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal parts. And we have got 1, 2, 3, 4 of them shaded in. That is equivalent to our bottom fraction, which has been split into 1, 2, 3, 4, 5 equal parts, with 1, 2 of them shaded in. And again, if I look at 4 divided by 2, it gives me 2, and 10 divided by 2 gives me 5. So I can use my multiplication and division facts to help me there. Now on Teams, I have put in your fraction rules, but you've got 3 different activities. Have a go at shading in the tables again to help you out with it. And good luck. Use the fraction rules to help if you need to. I believe that activity 2 has also got scaffolds further on in the PowerPoint that you can use as well.